Okay, let's dive right into this explainer and step into the high-stakes coliseum of the Cambridge 0625 physics exam. Today, we are focusing on the absolute ultimate boss battle of the entire syllabus. We're talking about thin lenses and ray diagrams. Now, if you're studying for Cambridge physics, you already know that this topic is an absolute beast. It covers the action of converging and diverging lenses on a parallel beam, focal length, real and virtual images, magnifying glasses, and the physics behind the correction of vision. It's one of the most rigorously tested areas, and it demands extreme precision. In this arena, literally only the prepared survive. So strap in, get focused, because we are going to completely transform the way you approach these complex, multi-stage problems.
Here is our battle plan for today's session. We'll start with Act 1, the challenge. Then we'll move into Act 2 to reveal the core concepts and strategy. In Act 3, we'll look at the transformation of failing answers. Act 4 is our interactive workshop. And finally, Act 5 will build your final system.
All right, Act 1, the challenge. Let's look exactly at where most candidates instantly lose their marks.
So why exactly are multi-stage lens problems the hardest nuts to crack? This is the core dilemma pulled straight from the principal examiner reports. To really understand this, let's meet two hypothetical gladiators in our arena, Alex and Sam. Think of them as the avatars of the two most common fatal mistakes students make. Alex is our human encyclopedia. When faced with a complex question about thin lenses, Alex absolutely overloads the answer with raw physics facts, but provides zero analytical depth. On the other side, we have Sam. Now, Sam understands the physics, but constantly rushes, skipping the crucial step of actually decoding the command words and completely missing the formatting requirements. Both of them struggle immensely to connect disparate concepts. Because listen, it is one thing to memorize the dictionary definition of a converging lens, right? But it's an entirely different, far more difficult task to logically connect the focal length of that specific lens to the formation of a virtual image in a real-world scenario. If you treat a multi-stage lens problem like a simple vocabulary quiz, you are walking right into a trap.
Think about their flawed answers for a second. Alex gives a massive, rambling paragraph about how light bends, but completely ignores the specific context of the question being asked. Sam drops a quick one-sentence answer that completely lacks any structural logic. Both are bleeding marks. Why? Because the Cambridge assessment framework aggressively prioritizes analytical depth and contextual logic over simple, rote memorization. As the academic benchmarks clearly state, you absolutely must demonstrate logical, structured reasoning. Superficial breadth, just listing everything you know about light, simply will not cut it. You have to evaluate the evidence, identify the given information, and solve the problem systematically.
Moving on to Act 2, Core Concepts and Strategy Reveal. It is time to gear up and arm yourselves.
Let's start with a non-negotiable foundational concept. Examiners report year after year that candidates constantly confuse key terminology. You absolutely must know that the principal focus is the specific point on the principal axis where a parallel beam of light converges after passing through a converging lens. And for a diverging lens, it's the point from which the parallel beam appears to spread out. Using a visual story method to encode how light bends through these lenses is your very first crucial tactic. Try this. Imagine a converging lens as a giant gathering hug, physically pulling all the parallel rays together to a single concentrated point. Then, imagine a diverging lens as a spreading explosion, systematically scattering the rays outward from a virtual origin point. Anchor these vivid definitions in your mind right now, because precise terminology is the bedrock of your exam answers.
Now for the real secret weapon, the method mark strategy, paired with the Peel framework. Point, evidence, explanation, link. Cambridge heavily awards points for your process, not just your final answer. Step 1. Identify the key elements from the text or tables. Step 2. Apply the relevant principles, like setting up the correct ray diagram for a real or virtual image. Step 3. Execute your analysis with absolute clarity in your working. This is where your Peel framework shines. Make your point, back it up with physics evidence, explain the mechanics, and link it back to the question. Step 4. Verify your results. Does the focal length actually make sense in this specific context? And Step 5, present your answer in the appropriate format using proper terminology. This systematic sequence is exactly how you secure those elusive method marks.
Before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Welcome to Act 3, the transformation. Let's see how we take failing answers and turn them into top-tier marks. Imagine a flawed ray diagram for a magnifying glass.
The candidate frantically draws a real image instead of a virtual one, completely misunderstanding that the object absolutely must be placed between the lens and the principal focus to act as a magnifier. Now, envision the perfect method mark ray diagram. In this perfect version, the rays correctly diverge after passing through the lens, and the virtual rays are traced backwards with perfectly straight dashed lines to form an upright, magnified virtual image. By shifting from just guessing facts to logically deconstructing the problem, we completely transform the answer. The student identifies the key elements, executes the analysis with crystal clear notation, and mathematically verifies that the outcome matches the true real-world behavior of a magnifying glass. Those red pen marks suddenly turn into green check marks.
And this brilliantly illustrates why you must justify your decisions with rock-solid evidence. The Cambridge syllabus literally states that top-performing students exhibit connected, conceptual understanding transferable to unfamiliar contexts. So what does this actually mean for you? It means if you get a question about the correction of short-sightedness, you cannot just casually say, use a diverging lens and move on. No way. You must link it back to cross-topic physics principles. You need to explain that short-sightedness occurs because the eye lens converges light rays too strongly, focusing the image in front of the retina. Therefore, a diverging lens is explicitly required to spread the parallel beam slightly before it even enters the eye, which allows the eye's natural lens to finally focus the image perfectly on the retina. That is what we call connected understanding.
Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at @acetheexams_IGCSE, to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @aceexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
All right, Act 4, Interactive Workshop. It is time for you to step into the arena and test your skills.
For Challenge 1, we have a 60-second visual data scan. Think about the complex physics data tables you see in exams. Notice how a converging lens makes the parallel beam intersect at the focus, producing both real and virtual images depending entirely on object placement. But then look at the diverging lens. The beam spreads from the focus and it produces virtual images only. In the actual exam, you need to extract these relationships instantly before the timer runs out. If a question asks for a real image, you must immediately eliminate diverging lenses from your options. Boom, half the work is done just by understanding the core trends.
Moving on to Challenge 2. I want you to mentally pull up a sample paragraph you might write for a tough lens question. Now, actively find the flaw in your paragraph by checking it against these 3 fatal mistakes pulled straight from the principal examiner reports. First, are you forgetting the proper presentation format? Second, are you completely failing to check your working? And third, and honestly, this is the biggest one, are your answers not specific to the given context? Think about it. If the question is about correcting long-sightedness, your answer cannot just be a generic copied and pasted rant about focal lengths. It must specifically address how a converging lens moves the focal point exactly onto the retina. Context is absolutely everything.
As the examiner commentary constantly reveals, losing easy marks often comes down to simple terminology confusion. Consider this a massive examiner alert. Always define your terms clearly before you use them in extended responses. If you are going to throw around a term like principal axis, you need to ensure the examiner knows you understand it's the specific line passing symmetrically through the optical center of the lens. Don't leave them guessing. Precision is power in the Cambridge arena.
Let's put this into practice for Challenge 3, Speed Writing. If you had to break down a problem right now, could you mentally execute the deconstruct, solve, evaluate framework in 30 seconds? You must identify the given information, break the problem into logical steps using your Peel framework, execute the ray diagram, and then pause to check for reasonableness. If you are designing a magnifying glass, is your final image actually upright and magnified? If it isn't, evaluate your evidence, identify your limitations or the bad assumptions you made, and correct your path immediately. This framework is exactly what separates top-tier candidates from the rest of the pack.
We've reached Act 5, the final system. Let's bring everything together so you can walk into that exam with absolute confidence. Let's formally recap the ultimate physics success blueprint. These rules guarantee top marks because they ensure you're demonstrating the exact analytical depth examiners are desperately hunting for. First, decode the command words. Are they asking you to state, describe, or explain? Those are very different tasks. Second, apply the method mark strategy with the Peel framework to show your complete logical process. Integrate the time management matrix. Allocate your time strictly based on the marks available for the question. Don't spend 10 minutes on a 2-mark definition. Third, use the deconstruct, solve, evaluate loop to catch your own errors before the examiner ever sees them. And finally, maintain contextual logic. Always connect your physics principles back to the specific real-world scenario given in the prompt.
Students who implement these physics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. The knowledge is yours now, but the application requires your ultimate focus.
Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at Ace the Exams IGCSE to excel in your Cambridge examinations. Subscribe right now to at Ace the Exams IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for physics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.